Okay, we are recording. So let me go back to where we were doing last time. So we were programming the DES algorithm, and we finished to program the DES function. So let me edit it again. So at the beginning, we have the table that we need to use. For example, the PC1, PC2, EP, the Xbox. We have 8 Xbox. The initial permutation, the inverse of the initial permutation. We did the XOR function, apply table function, apply box function. With the compute key plus, we can compute K plus. With the compute sub key, we can compute all the 16 sub keys. Each key is 48-bit long, as you remember. The F function, remember that the function are 4 steps. They are implemented here. So first I apply the E table. Then I XOR the result of the E table with the subkey of the iteration. Then I apply the Xbox. I divide the result of the XOR, which is 48 bits, in 8 group of 6 bits. And I apply for each group of 6 bits the S box, no? And then I apply the permutation table, and this will be the result of the S function. This is the definition of a round. We saw it. And this is the encrypt function. Okay, so let me bring some exercises here. Exercise 3. So let's go to this one, exercise 4. Have you seen in the lecture, to work with DES, it is imperative to have a fast way to convert a binary number to hexadecimal, and vice versa. Hence, you are asked to write 2 functions in Python as specified here. So a function is called bin2x, and it's going to convert a binary number stored in a string or encapsulated in a string into an hexadecimal number. So the first function called bin2x, the first function is called bin2x. We will use it to convert a binary to hexadecimal. The function has a unique parameter consisting of a string of character containing a binary number and return a string of character with the hexadecimal equivalent. So here, this is what we want to implement. The first one that we want to implement. And there are some examples. If you call bin2x of this binary number, it should return 8CB0. So look at the 8. The 8 is here. This is 81000. C is 1100. B is 1011. And 0 is 0000. Okay? So let me copy this. And let's go to the virtual machine and implement this function. So help me with that. What do you suggest to do here? So when you convert from binary to hexadecimal, what should you do? You take the binary number. For example, if I give you this binary number, what you will do is what? First, you divide the binary number in group of 4 bits, isn't it? And you know that each group of 4 bits have an hexadecimal equivalent. For example, 0111 is 7, and 0101 is 5. So this is the value in hexadecimal. Let me put another one, for example. Let's say that we have The first thing you will divide by a group of 4 bits. And you will take each group of 4 bits and convert it to an hexadecimal. So A, C, 0. Okay? You can see this is A, this is C, and this is 0. Okay, so we need to do that. So they might give me a binary number like this one. What will happen? That if I try to do group of 4 bits, the initial number of only 6 bits. So the first group will only have 2 bits. So I can do left padding. Okay? And then I have group of 4 bits. So the first one is 3, and the second one is D. So I might have to do left padding if the number of bits is not a multiple of 4. If the number of bits is a multiple of 4, I don't have problem. So let's program that. So the first thing that I want to check is that the number of bits in bin string is a multiple of 4. And if it's not, I will do left padding. So what can you do here? So you might have to add 1, 0, 2, 0, or 3, 0, depending, no? For example, here, in this case, we add 2, 0 on the left. But it might be 1, 0, it might be 3, 0, it might be 2, 0, or nothing to do because it's already a multiple of 4. So I might say, for example, something like that. Why the length of the parameter, which is being str, divided by 4, give me a modulus that is different of 0. What should I do? I should add 1 more 0. So I will do what? In string equal 0 at the beginning plus the value of bin string. Isn't it? This will do the padding. Do you agree with that? So this while I can pass 0 time, 1 time, 2 time, or 3 time inside it, no? According to the length of bin string. Okay, when I arrive here, I know that multiple of 4. So I can do group of 4. So for each group of 4, I can convert the group of 4 into an hexadecimal. So you might want to use a dictionary if you want. We can do a dictionary. You remember dictionary in Python? Let me define a dictionary. A dictionary is association between dictionary are pairs where you will have an index and the value associated with an index. Let me do a reminder of what is a dictionary. So for example, let me define a dictionary that is empty at the beginning, no pair. And I'm going to put, for example, let's say that I want to do a converter between numbers and the way that we write the number in English. For example, I can say d sub 1 will be 1. D sub 0 will be 0. For example, d sub 9 will be 9. But anytime I can say what is d sub 1 or what is d sub 9. Okay, this is a dictionary. So here we can define a dictionary and we say, for example, because we want to go from 4 bits to 1 hexadecimal, this group of 4 bits will be the hexadecimal 0. Okay, this is one pair. Another pair, this group of 4 bits will be the hexadecimal 1. This is a second pair. another pair. This group of 4 bits will be the hexadecimal 2. Let's put another pair. This group of 4 bits will be the hexadecimal 3. There are other ways to do that, no? Let me continue here. So then we have 4. 4 in binary will be that. Then we have 5. 5 in binary will be that. Then we have 6. Then we have 7. Let me copy this line and add more pair. Then we have 8. Then we have 9. Then we have A, 1010. Let's put it in capital. Then we have B, 1011. Capital B. And we have C, 1100. We have D, 1101. We have E, 1110. Finally, we have F, which will be 1111 for F. Okay, so I put 16 pair inside my dictionary. So what should I do here in my function? I do here. So first, I do padding, left padding if it's necessary. Then I will go for each group of 4 bits. So how can I say for each group of 4 bits? I can say for I in range of what? So length of the string. The string is called bin str. That I'm going to divide by 4. So I can go by a group of 4 bits. And remember, if you just use forward, it will be the real division. If you use forward slash 2 times, it will be the integer division. So I need the integer division here. So what should I do? I need a variable that I call result that will have the hexadecimal string. So it will start with empty string. And now what should I do? I should concatenate to result the hexadecimal. How do I get the hexadecimal? So we have a dictionary. I'm going to put dictionary of the 4 bits. And how do I get the 4 bits? How do I get the 4 bits? So I will go from index for I to index 4 times I plus 4, isn't it? So when I is 0, look, I will take substring of 4 times 0 will be 0, and 4 times 0 plus 4 will be 4. So I will take index from 0 to 4. 0 is inclusive, 4 is excluded. So really from 0 to 3, which is the first 3 character. When I is 1, this will be 4 times 1, which is 4. And this will be 4 times 1, which is 4 plus 4. So I will go from 4 to 8. 4 inclusive, 8 exclusive. So I will go to 4 to 7. This is what I need to do. And at the end, I will return result, isn't it? So this is done, should work. So I'm going to verify it. So remember last time what we were doing? Every time that we were doing a function, we were verifying if it's work or not. So here, I'm going to do it. So I'm going to call Python 3 in interactive mode. And I'm going to tell it to load the content of the file days.py. Oh, I keep this comment at the end. Let me remove them. The explanation that I gave you. So of course it say that I have a problem here. Let me remove all this. Okay, so we are at the end of the file. There is no more information. So I have to reload it. So let me exit with Control D and reload it. So the function is called bin to x. So let's see if it's work. Bin to x, or for example 0. Should give me 0, 0, 0, 0, no? It's a binary to hexadecimal, no, it's 0, correct. If I put, for example, 7, oh, 7 is not a binary. If I put this, let's put 7 like that in binary, it says 7, okay. If I put, for example, let's put this one, so what is the result here in hexadecimal? So we have a group of 4 here, which is E. And then we have a second group of 4 here, which is 5. So it should say E5. Correct, no? If I put, for example, this, what will be the result? So the first, here, we have a group of 2, which is 3. Then we have a group of 4, which is 9. Then we have a group of 4, which is 7. So it will be 3, 9, 7. Okay, it does work. So you convert a binary string into the hexadecimal string, okay? So this function works. Let's see what else they ask us. So they ask us the inverse function. If you look, now we need to do a second function that is called x to bin. The second function is called x to bin. It will convert from hexadecimal to binary. So they say, since it is confusing to read a long binary number, we will allow user to specify a separator every 4 bits. Hence, the function will have 3 parameters. The string that I want to convert from hexadecimal to binary, a possible separator after 4 bits, another possible separator after 8 bits. Okay, so here we have some example of how we are going to call this x to bin. So if we call x to bin, the number is ABCD, it will just convert, this is A into binary, no? This is B, 1011, C is 1100, so this will be C, and D is 1101, okay? So this will be the D. Now look at, if I take ABCD again, but I say after every 4 bit, I want a write space, and after every 8 bit, I want a write space. So look at, this is A, and we have a write space after 4 bits. This is B, and we have a write space after 8 bits. Then this is C, and we have a write space after 4 bits. And this is D. Okay? To make it even clear, let's say that the hexadecimal string that you have that, and you don't want write space after 4 bits, but you do want write space after 8 bits. So look, this is 9, then we have A. So between 9 and A, we don't have any separator because we didn't specify a separator after 4 bits. Then we have this write space because we say we want a separator after 8 bits. Then we have 6, 7. So this is 6, 0, 1, 1, 0. This is 7. And between the 6 and the 7, we don't have separator. Then we have a separator of 8 bits. Then we have 3, 1. So this is 3, and this is 1. Good. Look at this example here. Let me maybe try to put it in one line, so it's easier to understand. Still don't want to do it in one line. Okay, here it is in one line. So we have 8C37AA20. And we want a separator after 4 bits, which will be a space, and a pipe after 8 bits. So look at the first 4 bits, a space. Then after 8 bits, we have a pipe. 4 bits, a space. After 8 bits, we have a pipe. Okay? So the separator 8 is to separate bytes. And the separator 4 is within a byte. You separate this nibble with this nibble by the separator. Okay, let's make it clear because binary can be very long, so it's good to have separators sometime. So let's do this function. So I'm just going to copy it here. As you can see, this is called a positional parameter. And this is called a nameIt parameter. We have 2 nameIt parameters and 1 positional parameter, if you remember Python, no? So define the function here and start filling it. So what should we do? So we might have a problem. Let's say that the person sends something like that, 7A03. So the problem here is need to do padding. In this case, at the beginning, and put 078A03. So sometime we will need to do padding. And when we do padding, we just have to add 1 0. So, which means that according to the separator that we are going to put, we want 0 first. Then we need the separator of 4 bits. Then we need 7. Then we need the separator of 8 bits. Then we need 8. Then the separator of 4 bits. Then we need A. Then the separator of 8 bits. Then we need 0. The separator of 4 bits. And then we need 3. This is what we need, isn't it? So it might be possible that we need to do padding, but if we need to do padding, it will be just 1 0 that we have to add to complete a byte. Okay, so which means that the length of the string must be a multiple of 2. So we can say if the length of the string that you give me, which is called hexadecimal string, is not a multiple of 2, I will add hexadecimal string. I will add at the beginning a 0, a left padding 0. Now we know that we have a multiple of 2. So what can we do is what? Let me define a dictionary. I want to define a dictionary that will be the inverse of this one. So 1, 2, 3, 4 line. Let me copy this 4 line. So we need a dictionary that will take the hexadecimal 0 to the string, the binary string 000. Then the hexadecimal 1 to the binary string 0001. Then the hexadecimal 2 to the binary string that is here. Then the hexadecimal 3, the binary string that we have here. Okay, the first line is okay. Then the hexadecimal 4 to this string. Then 5 to this string in binary. Then, for example, 6. It's a way to do it, no? You can do it other ways. That's okay. to the string, then 7 is binary string, then we will have 8 to the string in binary, then 9. So we put index, colon, associated value, no? So the index, for example, here will be A, colon, associated value. It's a pair. So the index will be here B, colon, the associated value with B. Okay, we still have to do the last line to get it full. So we will have C, the associated value of C is this one, which is 1100. D, the associated value will be 1101. E, its associated value, which is 11110. And finally, F in the table, which associated value will be 1111. Okay, so I did define a dictionary that has 16 pairs. So now that I know that the string is a multiple of 2, what should I do? So look, you can take group of 2 nibble and work on them. So the first group of 2 nibble, I will put it outside the loop because there is no separator at the beginning. So let me take the first group of 2 nibble. Call it, for example, nibble 1 or digit, hexadecimal digit. Let's call it digit 1. This might be confused with D. So nibble 1. How do I get the first nibble of the hexadecimal string? This will be to 0. The second digit will be to 1. Okay, so what should I do? I need to compute a result. So let me start. I can just do it here. What will be the initial value of result? So I'm going to call D sub nibble 1, isn't it? Concatenated with the separator 4, with D of nibble 2, isn't it? And then now I can do my for loop for the rest of the byte. So I'm going to do a for loop for I in range of what? So I'm going to avoid the first byte because I already did it outside the for loop. So I'm going to start in 1. And I'm going to go where? To length of the string divided by 2, isn't it? Okay, so here I can compute my first nibble, nibble 1. It will be what? Hex string of what? I, isn't it? And nibble 2, which is the second hexadecimal digit, will be hex string of 2 times e plus 1. And what should I do? I need to update result. So result will be what? The concatenation of the previous result plus, let me just copy that. Before that, I need a separator. I need separator 8 plus, which is concatenated. Do you agree with that? I need to put separator 8. Look at the first one. In the first one, I just do the first digit, separator for the second digit. This is what I put here. Then, for all the subsequent bytes, I put separator 8, concatenated with the nibble, with the digit that I changed from an hexadecimal to 4 binary, the separator 4, on the hexadecimal digit that I convert to binary. If you look, the subsequent is also the same thing. So it's why the first one I put it outside. And I will just return the result. Walk, let me remove that. Okay, let me save it. And let's try if our function works. So it's called x to bin. So I'm going to call Python in interactive mode and tell Python to load this file. Okay, we forgot here the colon to say that a block is coming. So Python did tell us that we forgot it. Let me load it again. Okay, so eggs to bin. I'm not going to specify any separator. So there will be one, two, let me put here this. So let's see. This is A, 1010. This is 9, 1001. B is 1011. C is 1100. 0 is 40. And 1 is 0001. So the conversion was okay. So let me put a separator of 8, which will be, for example, a pipe. Look at every 8 bit, I have a separator. So we should have A9. So this is A9, a separator of 8. Then we should have B, this is B. This is C, a separator of 8. This is 0, and this is 1. So separator of 8 work. Let's put up a separator of 4, which will be a space. So look, between the first nibble and the second nibble, we have a space. So we have A space 9. This is a separator of byte. So we have B space, the first nibble space, the second nibble of the byte. Then a separator of byte. And we have 0, separator of nibble, and then we have the byte. So it looks like it works, no? Let's verify that if it has to do padding, it do it correctly. So let's put another value, for example, 1 to A. 1 to A should be, it has to do padding at the beginning with 0. So it did padding at the beginning with 0 to complete a byte. Then we have 1, then we have 2, then we have A. Okay, so my function works. So now that I've done that, let's do our program. So I want to do a program, last time I was telling you, that will work like that. You will call the desk script, and you will specify first the plain text, and then the key. And it will show you the ciphertext for this. So we are going to use argument. Since I'm going to use argument, let me at the beginning import sys, the packet sys. I can manage argument. So the first thing, let's put a comment here. This is our main program, no? Our main program start here. Before that, we were doing functions. Okay, so start, beginning of the main program that will call the function. Okay, so first of all, I want to check if the person did specify the plain text on the key. So the number of arguments have to be 3 because the command name, the plain text, and the key, 3. So I'm going to say if the length of the array sys argv is not 3, there is a problem. So I'm going to tell the person there is a problem and correct the problem. So I'm going to help the person about the usage. So the usage have to be the following. So this, I want to send it not to the standard output, but to the standard error, which is the screen by default. After that, I want to show the usage. So the name of the program, you will put here the plain text, and you will put here the key. Okay, so the person know how to use it. And the name of the program will be sys.argv sub 0. I need to exit because there were a problem. So I'm going to exit with an error code, which will be 1. And here, if I come here, there is no problem. I'm going to exit with an error code of 0. So let's see that if I don't use it correctly, for example, let me put here plain and key. This will be the correct usage. Is the correct usage? It didn't complain. And if you look at the return status is 0 because I exit here. I exit here in this exit 0. Now let's put something that is wrong. I forgot to put the parameters. So it's tell me, forgot here the format, no? Dot format, parentheses, this guy, there is only one. I will have, unfortunately, to go out. Oh, no, it's okay. So I'm going to do it again. So look at, it's telling me if you want to use it, you have to specify the plain text on the key. And of course, if I look at my error status, it's 1 because I exit with 1. Okay, so let's say that the person typed the plain text. Let's define a variable that we call plain text. Where is the plain text? How do I get the plain text? And how do I get the key? The plain text is where? It is in sys.argv sub 1. So sys.argv sub 0 will be this one. Sub 1 will be the plain text. And sub 2 will be the key. So if I want the key, it is in the array that is called argv, and the index is sub 2. Okay, so let's compute the ciphertext. Ciphertext. So those are in, let's say that they are in hexadecimal. I ask the person to put them in hexadecimal. So let's compute the ciphertext. How do I compute the ciphertext? I did create a function that is called encrypt. So let me go back to it. By the way, encrypt is with Y. Nobody say anything. Last time I wrote like that, I just realized. Encrypt is with Y. Remember, you have to tell me when I make a mistake, no? So we have this function that is called encrypt. We are going to use it, and it has 2 parameters, the plain text and the key. So let's go to here and put, we are going to call the function encrypt. We are going to pass the plain text. We are going to pass the key. Okay, I want to show the result in binary. All those will be binary. So to make it easier, let's define, okay, let me do something. Let's say that this is eggs, plain text in eggs, key in eggs. So to call this, I need the plain text in binary and the key in binary. And this will give me the cipher text in binary. So I need to compute the plain text in binary. How do I compute the plain text in binary? From the plain text in hexadecimal. We did a function that is called bin to eggs, isn't it? No, eggs to bin, because I need it in binary, sorry. So it will be, it is hexadecimal, and I need it in binary. So we are going to call x to bin and put the plain text in hexadecimal. I'm going to put here the plain text in hexadecimal. It's going to give me the plain text in binary. I need the key also in binary. So how do I get the key in binary? I have the key in hexadecimal. So I'm going to do eggs to bin of the key that I have in hexadecimal. So I have everything in binary and in hexadecimal. Oh, I have the ciphertext in binary. I don't have the ciphertext in hexadecimal. So let's obtain the ciphertext in hexadecimal. How can I do that? I have the ciphertext in binary. So I'm going to call the function that is called bin to eggs. And I'm going to pass it the ciphertext in binary. And it will convert it to hexadecimal. So let's show the result now. I'm going to print all the result. So plain text. And we are going to show the plain text in hexadecimal. So we have a variable that is called plain text x. Now we are going to show the key. The key will be key in hexadecimal. We have also a ciphertext that we computed. Ciphertext. I'm going to show the ciphertext in hexadecimal. So cipher in hex. Let me see if we can do it, if it's work well here. So I'm going to put the example that we have in the slide. We have the slide in some part here. They are here, no? So look at, this is the plain text. So we can verify it. Let me copy it. Here. Okay. The key is this one. Let me copy it. Here. And let's see my program work. So plain text, there were a problem in line 251. Oh, it's ciphertext. It's not cipher, it's ciphertext X. So let me go to line 251. 251. It's ciphertext. Okay, let's run the program again. Okay, so all the results are in hexadecimal. So let's verify that this number is the one that we have in the slide. So if I show the slide, let me put it on the side. So we have 8080 B9, B9, blah, 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 blah. Let me take the last 2 bytes. 9D5C, 9D5C. It did work, as you can see. So I want to show them also in binary. So let me copy this 3 line. and show them in binary. To make the difference, let's separate the hexadecimal from the binary with a line of dash. And instead of hexadecimal, I want them in binary here. Binary here. So we have variables that have them, no? Binary here. Okay. So let me run again the program and see. So this is the plain text in binary. We can verify it, for example, 0A76, 0, 0, oh, 0, correct, A, correct, 7, correct, 6, correct, okay? So you can verify it. So we put the plain text, the key, and it shows us the result of the ciphertext in hexadecimal and in binary. Very good. Now, I want you to do the decrypt function. So we can write a decrypt function here. So we have the encrypt function. Here is the encrypt. I want to write the decrypt function. So for that, let's see the slides to see what change we have to make. So the first slide, which is in page 3, this one, is the slide that we need to understand. So we have spent some time already. Let me go to my window machine better and open the slide. Is there introduction to this slide. So we need to go back from that. Let's see if we can manage it. Maybe the PDF is better, no? And I need it. Okay, I have the lower part here. It's enough. I think with that we can do things. Let me open Paint to write. And you have thought about the problem, so you should be very good in that. So tell me, what do you think we should do first to decrypt? This is the encryption algorithm. It starts here and ends here. To do the decryption algorithm, I have to go backward from the bottom to the top. So what was the last operation that we did in the bottom? We apply the inverse initial permutation. So in the decrypt algorithm, what should be the first operation that I do? I will apply what? So we have maybe this is too thick. We have a ciphertext that arrives. I have 64 bytes. What should I do first? I have to apply what? The initial permutation. Because the last thing that I did, I applied the inverse initial permutation. So here, to cancel the application of the inverse initial permutation, I'm going to apply the initial permutation. So I need to apply the initial permutation. After doing that, it will give me a number of 64 bits. What should I do? Here we invert the most significant 32 bits with the least significant 32 bits. So to cancel that, we are going to inverse them again. Because if you inverse them 2 times, you come back to the original result. So we are just going to apply a 32-bit swap. After that, what should we do? We should do an inverse round. We have to see what is an inverse round. No round. And this reverse round will be done with K16. So here, when we do the encoding or the encryption, we use first key 1. Here we are going to use key 16, such that the inverse round cancels the round 16. Then after that, what should we do? We should continue doing another round. So we are going to do an inverse round, but this time with key 15. So we will continue blah, 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 blah until the last inverse round. Inverse round with K1, with the key 1. Okay, so with that, I've canceled up to here. So what is the last thing that I have to do to finish my decryption? Here, the first step was apply initial permutation. So before exiting, I should do what? Apply inverse initial permutation. So apply inverse initial permutation. This is what we have to do. So we just have to find what is inverse round. But this is what we have to do, no? So the first time at the beginning, we apply the initial permutation. We swap the 32 bits with the 32 bits. We apply the initial permutation to cancel the inverse initial permutation. We swap the 32 bits to cancel this. We apply inverse round with key 16 to cancel the application of round with key 16. Blah, 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 blah. Up to inverse round with key 1. And the last thing that is left here in the top is that we apply initial permutation. So here we are going to apply inverse initial permutation. And we should have our clear text. So what is going to go out here, which will be 64-bit long, will be the clear text. Isn't it? So I just apply it backward. So let's do it. So first I apply the initial permutation, then I swap. So let me go back to my virtual machine, and we are going to do the inverse function, the decrypt function. So let me copy this one and modify this one. So how many lines I have to copy? Look at the power of VI. Look at what I'm going to say. From this line up to the line that have a return, the first line that have a return, copy it. Say 8 line. So if you look 1, 2, 3, 4, 5, 6, 7, 8, that was correct. Now that is in the clipboard, I'm going to paste it. You see that? You will never do that in Nano. That's why people don't use Nano. People that have more experience go with tools that are much more powerful, no? So let's do decrypt. So the first thing that we have to do, let me show you again, we have to apply the initial permutation, which will cancel this one. So we are going to apply on the plain text the initial permutation. It is already there. We got a result. We are going to compute all the key. So look at, we apply the initial permutation, we swap them, then we compute the keys because we need the keys, then we apply inverse round using the key from the key 16 to key 1. So we are not going to call round, we are going to call inverse round. We need to find out what is inverse round. And we are going to go from key 15 to key 0 by step of -1. So key 15 inclusive, no, it's keys, yeah, key 15 there. Because the key here are from 0 to 15, they are not from 1 to 16. So from key 15 inclusive to key -1 excluded, which means to key 0 included, we are going to apply that. And finally, we are going to apply the inverse initial permutation. So we are going to apply inverse initial permutation. So I have decrypt already done. I just need to find out what is this inverse round. Do you agree with what I wrote here? So we need to see what is this inverse round. I need to do this inverse round. So there is a round here. Let me copy it also. So I'm going to say from this line up to the line that have, for example, a return. This is the first line that have a return. Copy it. Paste it here. And here we are going to do inverse round. So we need to know what is this inverse round. So let's see. Let's see what is a round, and let's see how we create inverse round. So let me go back to my PowerPoint presentation. Maybe it's better this one. And let's see what is a round. So I asked you to think about it, so you should know what we have to do. Okay, so here I have it. Let me put my board. Okay, so help me. Look at, we have these equations. What we need to do, because we need to do, here we go from top to bottom. So inverse round will go from bottom to top. So we need to go from L, we need to go from Li, Ri to Li minus 1, Ri minus 1. So using that, let's do it. So for example, I need to go to Ri minus 1. So look at, we have here the first one. The first one is very easy. How do I get Ri minus 1? From these two inputs, from Li and Ri. It is there. So I don't have to make any effort. It is there, no? So I can say that Ri minus 1 will be L sub I. So I already have one of the two results that I need. Now I need L sub I minus 1 in function of L sub I and R sub I. So what do you think? What can we do here to get L sub I minus 1? This is what I'm searching in function of the two input. And the two input for me is L sub I and R sub I, because I go from bottom to top this time. So we can start with the second equation that we have. We have this one, f of Ri minus 1 Ki. What do you think I can do here? What do you propose to do? Because you want to find Li minus 1. You want to find this guy. What is A XOR 0? Okay, let's go to the definition of the XOR first. What is A XOR B? By definition, A XOR B is this, isn't it? So what is A XOR 0? It will be A. How do you say that in English? The negative of A? Or A bar? Okay, let's say A bar. A bar times 0 plus A times 0 bar. So this will be 0. And the second term, 0 bar is what? Is 1. So the second term will be A times 1. And A times 1 is A. So A XOR 0 is A. And what is A XOR A? It is 0. Let's do it. It will be A times A bar plus A bar times A. So A times A bar is 0 plus 0. The result will be 0. So we are going to apply this property to find this term. So if I want this term to disappear, so I can have Li minus 1, what should I do according to what we just see? What we just saw? What can I do? I can XOR the left term and the right term of the equation with this, isn't it? If I XOR the left and the right part with this, I will find Li minus 1. So let's do it. Let me go back to the black color. So if I XR the left part with this, I will put here F of Ri minus 1 Ki. And the right part will be L sub I minus 1 XOR F of Ri minus 1 Ki XOR the same thing, because I apply it on the left term, on the right term, no? So F of Fr minus 1 Ki. Is it okay for everybody? So what can I say about this? A XOR A is 0. So this is 0. And 0 XOR La minus 1 will be what? Just La minus 1. So we can say that the right term is just La minus 1. Remember, we saw that A XOR A is 0. So this term XOR this term is exactly the same thing. So it will be 0. And 0 XOR A is A. So this is 0 in red. XOR L minus 1, it will be just L minus 1. So here we will have R sub A XOR F R A minus 1 Ki. So the second one that we need is here. Let me write it by changing left and right. So let me write it as Li minus 1 is Ra XOR F of Ra minus 1 Ki. So this is the second equation that I need to program inverse round. So now that we have both, we can program inverse round. So let me make it smaller. Can you still see it? There is no in between, unfortunately. Cannot go between. Take me from 50 to something that is much larger. Yeah, it take me to 50 to here. Okay, we can see both here. Well, what I can do is, let me cut this one and put it here. So we can see both better, I think so. Okay, we have both. So let's do that in Python. Let's put these two equations. So let me go back to my virtual machine where I'm programming. We are going to put that. So help me here. So look, the left part of the input will be the bit 0 to 36, 32. The right part will be the bit 32 to 64. It doesn't change. So what is the first thing that I need to compute? So the new right will be the old left. So the new right will be the old left. The new left will be a XOR. So the new left will be a XOR between, look at this XOR. It's a XOR between, oh, by the way, look at here we can go a little further away. This Ri minus 1, we can change it by Li. So this is not the best one. I still can do something more here. I can, according to the first, because I cannot have, this is something that I'm looking for. So this is Li. This is Li, and this is Ki. So that's the final one. It's not the one that I show. The final one is this one. So look at the new left is the XOR of the old right with the function with the old left and the key. So we are going to put XOR of the old right the all left and the key. The all left in F and the key. So this is the inverse round function. So this should decrypt. So we have the decrypt function because we did the inverse round and we did the decryption. So look, let's, instead of calling here encrypt, let's verify that our decryption work. So I'm going to call decrypt here. It's the only place that I need to call it. Yeah. So let me maximize now my virtual machine. I want to execute here, but I'm going to change. The key does not change. This is the key DA2C. It does not change. What I'm going to put here is the ciphertext. And as plain text, you have to give me this one. So let's do it. It's doing decryption now. So look, this is the new result. So I did put, of course, it says plain text when it's ciphertext because I didn't change the comment. But I just want to see that it works. Do you see that it works? The decryption algorithm? So now we can do something better. Here we are going to put an additional parameter that can be, for example, encrypt. or decrypt. So we will have 4 parameters. The name of the command, if we want to encrypt or decrypt. If we want to encrypt, this will be the plain text and the key. If we want to decrypt, we will put here decrypt, and this will be the ciphertext and the key. Okay, so let's change our program so it's allowed to encrypt and decrypt. So here, now I'm going to compare with 4. So if the person don't give me 4, I will explain the person how to use it. So I will tell the person a possibility if you want to encrypt is like that. If you want to decrypt, here you will put the ciphertext, of course. Ciphertext is like that. So let's see that the help is working well first. So let's say that, for example, I call the function like that. So it tells me if you want to use it, you use it this way when you want to encrypt, or you use it this way when you want to decrypt. Okay, so the help is good. It is done. So here I better put a if. So first of all, I'm going to put in OP for operation, what the person wants to do, the operation, if you want to encrypt or decrypt. Where is this store? How do I get the operation? How do I get this encrypt or this decrypt? It is where? You should know. It is where? So, So there is an array that is called sys-argv. So sys-argv sub 0 will be this one. Sys-argv sub 1 will be this one. Sys-argv sub 2 will be this one, or this one. And sys-argv sub 3 will be the key. So I'm going to take it from sys-argv sub 1. And of course, I can check that the person didn't misspell encrypt or decrypt. So I'm going to say, if the operation is not encrypt and the operation is not decrypt, there is a problem. If the person puts something different, I will tell the person, I'm sorry, I don't understand what you mean. So let's put here, let's put a message that say problem with operation, problem with the specified operation. And I'm going to show the person what the person have typed for the operation. And I'm going to tell the person possible value are encrypt or decrypt. So possible values are either encrypt or decrypt. And I'm going to exit with another code. So I know if I exit from here, the status error will be 1. If I exit from here, the status error will be 2. So it's different. So let's see. Let's say that the person say the operation is I don't know. Look at problem with the specified operation. You put I don't know. Of course, here you need to put either encrypt or decrypt. So if I look at the error status, it will be 2. Okay, it's to force the person to put either encrypt or decrypt. So if we arrive here, we know that the person specify either encrypt or decrypt. So if the person wants to do an encryption, That will be the code that we have here. That will be this code. So this code, I'm just going to indent it. Otherwise, if I come to the otherwise, the person wants to decrypt. So let me copy all this and just modify it. So I will say from this line up to the line that have a else, one line before, because I don't want to copy the else, copy. 14 line. Let's verify. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You see? I didn't have the necessity to count them. I'm going to put them here, and they are all that. So this will not be the plain text. This will be the ciphertext. Ciphertext in eggs. Oh, by the way, the index change. It will be 2 and 3. Okay? Because we put one more parameter. It's not 1 and 2 anymore, it's 2 and 3. So the ciphertext will be in sub 2. It will be in sub 3. So here I'm going to compute the ciphertext in binary. Ciphertext in binary. For that, I'm going to take the ciphertext in hexadecimal. Ciphertext hexadecimal and use the function hexadecimal to binary. Good. This is the key in binary. Good. So here, by the way, we have put decrypt here because we was trying the function. So I put encrypt back. Here we are going to decrypt. So we are going to receive ciphertext binary, the key in binary, and we are going to get the plain text in binary. And we want the plain text also in hexadecimal. So here I'm going to put plain text in hexadecimal. You take the plain text binary and you pass it through bin2hex. And I'm going to show the same result. Maybe I show the ciphertext first because the ciphertext was an entry. And the key, then the plain text. And here the same. Let me show first the ciphertext, then the key, then the plain text. Okay, hopefully it works. Let's see. So let's call it with encrypt. So that was in line 265. 265, we need an equal. Okay, it's not an assignation, it's a comparison. Okay, so the plain text is that, the ciphertext is that. Let's see with our slide. We have some result that we already have computed, so let's put those. Okay, here we have an example, so we can put it. Okay, so the example is the plain text is this, and the key I already have correct. So let me copy it. So I'm going to put as the plain text this. Let's see. So it gives me as a ciphertext, let's compare it, 8080B9 and the last 9D5C. It's work. So now, let me separate it. I'm going to say I want to decrypt this time. And I'm going to put as a ciphertext this guy. And of course, you have to give me this plain text. So let's see. And as you can see, this one, after the decrypt, have to be 0A76, start well, and have to finish with 2C36. 2C36, it's work well. So you see how we did the encryption and decryption, and how we did a command line where we say what we want, if we want to encrypt or decrypt. So encrypt will encrypt, and decrypt will decrypt. So now my question was also, why don't you do the same with triple des? So let's do it for triple des. Help me with that. I'm going to copy this one and call it triple des 2 keys, because we have triple des 2 keys and triple des 3 keys. So I'm going to modify triple des 2 keys. So I am editing in this moment not the correct one. So let me exit from here, and let me see if I have already the execution right, because it was a copy. So let's edit triple des 3 key. Okay, what should I change here? Let's do a function. Let's do 2 additional functions. Let's do triple des. So let's do encrypt triple des 2 keys. So we will have a plain text and we will have a key. So I show you the algorithm of triple des 2 keys again. This is triple des with 2 keys. This is the formula. So you receive key 1, key 2. First, you take the plain text and encrypt it with des with key 1. The result, you decrypt it with des with key 2. The result, we encrypt it with des using key 1. And this will give you the result of triple des. So we have the formula here. Let's try to keep the formula. So I have it here. Where is the formula of triple des here? Okay, it is here. Encrypt. Okay, so I'm going to put it so we can see it, and we are going to modify the code. Okay. We are going to, so tell me, here you have the formula. What should I do? By the way, plain text on the key. So I need to determine the key 1 and key 2 from key. How do I determine key 1? Key 1 are the most significant bit, the 64 most significant bit. So I will take the key from 0 to 64, isn't it? And key 2 are the least significant bit. So I will go from 64 to 128. So first, look at encrypt the plain text with K1. So we are going to call encrypt, that we already did, the plain text with the key K1. Then the previous result with the key 2. This is what we are doing here. Then encrypt the previous result with the key 1. And this is your result. Return result. So this is the encryption. So let's try it. So if the person say encrypt, we are not going to call encrypt, but we are going to call our new function, encrypt triple dash with 2 keys. Okay, done. So I want to encrypt, for example, let's take the same that we have previously, where it is. It was here in the top, no. So okay, here it is. I want to encrypt that with a key. So I will take this and this is not the key. The key have to be 128 bits. So I still have to type more. For example, let's type 00, which is the first byte, second byte, third byte, fourth byte, fifth byte, sixth byte, 7 bytes. Now I can do it. Possible encrypt. I didn't write encrypt well. So there is a problem. Oh, I have to put them in capital because my function is done for capital. So the A, the B, the D, and the E here have to be capital. Let me see. Is my key too long or too short? How long is this? I don't know. Let's compute it to see. So echo -n. How many hexadecimal it should have? What should be the result here? So it's 128 bits. So hexadecimal will be 128 divided by 4. So it should be 32. 30. So there is a byte missing. So let me do it again, putting 45 at the end. Okay. So look. Let's see if we find a triple desk calculator online to verify that. So, or I could have stayed here and open this and put triple desk calculator, but it have to be, because we can find different triple desk calculator. We need one that have 2 keys. Let me see. This one will work. Explain tech eggs. Triple desk. I don't know if it's 2 key. Doesn't say anything. This one doesn't have triple desk. Let me see this one. So they talk about key 1, key 2, key 3. It should be 3. Let's see if we find one. Otherwise, we verify by ourselves, and it will give us some work. Oh, we have the desk. we have the one that we did. So we can verify it with the one that we did. We did a des calculator. So I'm going to call des. So how do I verify that? First, we encrypt the plain text, which is this guy, with key 1. So why don't I define variable, key 1 and key 2? So key 1 will be, this is key 1. Key 2 will be this is key 2. Same size, both are 64-bit long. So I'm going to call des. I need to encrypt the plain text, which is this value, with key 1. Okay, so this is the ciphertext. Then I call des again, but this time I decrypt the result with key 2. Then I call des encryption the previous result Did I make a mistake? No, the plain text. The plain text, I take it here. Oh, what did I do? Oh, I cannot close the window, no? Okay, I'm sure it's work. So find a desk calculator, a triple desk calculator to verify that. Okay, one thing, I need you to participate more. Okay, you are people that know how to program. This is programming assignment and it's not complex. It's fairly simple. So I did tell you, think about it last week. Okay, so please participate more. You need to participate more in the course. We don't have exam, doesn't mean that you can just relax. Okay? You will have to program in some assignment. You have to get very familiar to all this binary. Okay, because this is cryptography and it's a way to protect us. Okay, I see you in 2 days.